Hey everybody, and welcome to the latest adventure of Blink. I am, of course, Blink, and you can find me on GitHub right here. Now, before we get started, I want to remind you to like and subscribe to the video, primarily because this season is an entire build. The whole thing goes together in a certain order, and if you miss an episode, you're going to have a hard time completing the build. So I want to make sure that you get those notifications right when they happen, and that way you can stay up to date with what we've got going on. Uh, this season, we're going to build the game Hangman, but we're going to do it in a really convoluted, complicated way to be able to show off lots of interesting DevOps principles. For instance, we've been playing with containers, and we're going to be playing with the construction of an API layer, and eventually we're going to even maybe get into some AI things by the end of the season. So all of these pieces need to come together in a certain way for you to be able to keep up. Let's dive in, shall we? All right, so before we dive in too much to the new code, I wanted to make a couple of corrections to what we had on last week's episode, because it quite frankly didn't work the way I expected. And I didn't uncover those things until I tried to take the next step. Sometimes that's the way this stuff goes, and you have to be flexible with it. So here's my chance to update and set the record straight. The first thing is last week I had a colon on the end of this line. Here at the if collection exists. So we're in the init mongo sh file. I've got this bash script to create the database collection if it doesn't exist already. And I messed up this if statement because I was shifting between Python and bash. And of course, in Python, you need a colon. In bash, you do not. So if you don't fix that, then this script will never actually run, which means your collection won't be in place when you need it to be. The other thing I added to this was a statement down at the bottom that just says the initialization script ran so that I could push it to a text file in the temp directory of the container. This gives you a quick visual ability to check and make sure everything ran successfully when you start up the container. Because in my testing, I found that I was starting up the container and it looked like everything was good, but nothing was happening. And it took me a while to go dig down in the logs and find out what went wrong. So I made this as just a quick way. It drops this file in the temp directory just to say, hey, I completed the startup process. So that's an important thing that you would want to have there. Something else that I ran into had to do with the way this Docker file was constructed. So the original version, if you go back and look in last week's branch, you'll see that I was copying the env file into the Docker container, and that's not necessary. The env gets automatically loaded as part of the process of spinning up the container, and so all of those environment variables are already set. I don't have to pass them in and do anything manual with it. So that was something I ran into as well that I wanted to fix. And of course, that change necessitated a little bit of a change to the way that the Docker Compose works. So if you look here at the Mongo container that we were building, you'll see that I've added some stuff in the build tag. There's a context and a Docker file. So I can specifically name these now, so that now I've got the ability to say we're operating in the current root directory of our project. I needed to be able to do this to make sure that I knew what the pathing was looking like when I got to the Docker file. Because if you spin up the Docker file and this is the context, you of course need to add in like folder names and things to make files match up right. So just something I did there for clarity's sake. I wanted to make sure that you could see those changes. Now, we're going to start digging into some of the things that we have to do to create the new version or the new additions that we're making. And today we're going to focus on the idea of an API layer. So if you looked in the diagram that I've got out there, you'll see that we're creating an API layer as a way to communicate with the database. It gives us the ability to separate the concerns of database entry from the rest of the game. And that gives us some flexibility in terms of the way that we maintain things and makes it easier later on if we want to change out database systems or use a different product altogether. we've got the ability to do those changes much more easily and safely. This is a concept called loose coupling, and it's really important in the space of distributed systems because you've got to be able to make changes to individual sections without affecting other sections. And if all of that database code were inside of our game, then we would have a serious problem anytime we needed to make significant database changes. So the ability to do this comes from the fact that we now have a compartmentalized API that's going to live in a separate container alongside our existing database container. So in order to build that, I'm actually not going to walk through all of the steps this week because this could be really long. This episode already looks like it's going to be a long one, so I wanted to cut things back and just make it a little bit more conversational. And we'll show you around what the changes are, but we're not going to live code on this one. So first of all, I created a db-api folder in our project. So this sits at the same level as the database folder, and it's just another component of our application system that we want to keep in the same project, but have separated so that we can work with it individually. And inside of this, we're going to create a few things. We've got an api.py file, we've got a Docker file, and we've got a requirements.txt file. So if you've done any Python work, you know what requirements.txt is. It is the way that you define the dependencies that are used within your program. And this makes it portable so that I can give this requirements.txt file along with the source code to another person, and they can just run a simple command to have their environment load all of the dependent libraries. This is one of the ways that we make things flexible, and in particular, this is important for Docker containers because when we load this into a Docker container, the container has nothing set up for us. It's going to be just a basic Python install. It doesn't have any libraries with it. So what we have to do is define the libraries that we're going to need in this requirements file and save those so that the container knows what it needs to download when it's spinning up. Now, we're going to start with the API, and we're just going to kind of talk through how this works. So we're using a framework called Flask. If you've not used that in Python, it makes it very easy to create an API type product. I suppose you could probably use it for anything that's sort of web server based, but the general gist of this is we're going to make HTTP requests to this API, and it's going to respond over HTTP with the data that we've asked out of the API. So we're going to spin up a container to hold the API code. It's going to run Python, and then we're going to put our Flask app inside it. And it's going to have connectivity over to that Mongo container that we made last week. Now, the next thing we do here, you can see I've got the app equals Flask name. This is just the initialization of the Flask framework. It's sort of a one-liner that you put at the top of the program so that it knows, hey, I'm building a Flask app here, and it needs to pull in all of the initialization work that happens behind the scenes. After we've done that, we have to set up a few things in order to connect to our Mongo system. So we're pulling from the same env file that we used when we built the database container. And all we're doing is grabbing those same variables, so the URI, and in this case we actually made a separate one for the API because they're slightly different depending on which container you're living in. But the database name and the collection name are always the same. So we want to be able to reuse those variables and keep them in a centralized location. So we're just pulling those in from the env file. You can see I've got a commented block here. When I was testing this locally, you can spin up the API on your local machine, not in a container. But in order to do so, you need to make sure you're still pulling in those environment variables. So rather than trying to figure out all of the working parts of that, I just threw the variables in here and put constant responses on them so that I could get it working. And then I commented this part out so that I could use the env when I upload to the container. Once you've done that, you have to initialize a Mongo client, and that just requires the URI variable that you pulled. And then you attach the database name and collection name, and I made separate variables to hold those so that I have easy access to those as I'm doing work. All right, so we're on line 24 now, and you see app.route. Okay, this is a tag that tells Python this method is going to be something that can respond to an HTTP request. So whatever your root URI is, like it might be localhost, or you might actually be uploading this to some place that has a domain name. So adventuresofblink.com or whatever. I don't actually own that, by the way. Don't go there. Whatever it is that you're using, you have the ability to do sub paths off of that. And so /add is going to be a post call that we can make off of whatever our root URI is. So it might be localhost 5001 is actually the port that this will be running on. /add becomes the address that you can reference this specific method by. And because it's an HTTP post, you have to set it up with all the proper parameters for that post to work. And we'll look into some of the details as we go through this. So you can see I've got a print statement here that I forgot to take out. I'll clean that up when I upload the code. In fact, I'll just pull it out now and get it out of the way. But you can see there's a data that I'm establishing all the things that were passed into the method in a variable where I have access to use them. So data is going to contain the JSON response, or the JSON information that was passed into the post request. So once we've got that, we have access to any parameters that were passed along. And we're actually going to validate for two of them in this case. So there is a phrase that we're expecting to be in there, and there's a hint that we're expecting to be in there. Now, Mongo's is a sort of special kind of system that it doesn't require you to have a schema for the database. And I think we talked about that a little bit last week, that you don't have to define all of the fields and set up the structure of the database ahead of time. You can sort of do it on the fly by passing in data, and it's going to adapt and adjust. But that also means that we have to be more careful about what we validate. We need to make sure that the things we expect are in the record before we try to use them. Otherwise, we cause errors that are not good for the end user to experience. So we're going to validate here, and it simply returns an HTTP 400 error that says, hey, I didn't have this parameter, if it doesn't find it in the list. Now, once we've done that, remember what we're doing is adding an item into our phrases list. So this phrases list is where we store all of the game boards that are available to play on the Hangman game. And as we add a new one to the list, what we're doing is creating a new item. And so you see on 36, we're actually creating this new item object. And we're going to put the phrase into it. We're going to put the hint into it. And then I've added two variables here to talk about metrics a little bit. One of the things you can do as you're writing your code is create variables that go into the object that you keep track of in order to use for metrics purposes later on. So I'm using a last used timestamp, which we're going to initialize as null, and I'm using an access count, which we're going to initialize as 0. And the reason I'm using the access count is I'd like to know how many times this board has been pulled and put on the screen. And in fact, maybe when we're playing the game, we can alter the game to prefer picking boards we haven't used before, just to keep things more fresh. And so it will try to use the last used timestamp as well as the access count to know whether this board has come up in the randomizer too much. And maybe we ignore it and we weight the boards that haven't been used as much so that we can experience more interesting games along the way. Now, after we've built the object, we're ready to insert it to the database. And one of the cool things about Mongo is that it's kind of a one-liner to just take care of that. So collection.insert1. Here's a new item, put it in the database. And we don't have to worry about the schema. We don't have to worry about any of the details. If the object was created successfully, it's going to fall right into the database in this way, and it's going to be part of that collection. And then we return a response to say, hey, we have added an item, and we pull the auto ID that's generated by Mongo in order to just make that part of the HTTP 201 that goes back to the user. 201 is, interestingly enough, a really cool thing that I discovered. I'd never used it before. I'm always used to 200, okay. But 201 actually means the object was created. So that was a really cool thing for me to find out about as I'm going through this exercise. And that's all it takes to add a new item to the list. All right, so we're going to talk about the next route now, which is random. And random is exactly what it sounds like. It's the ability to arbitrarily select an item out of the database. I don't want to give any sort of indications of what I'm doing. I just want you to pull one and let's use it. So we're not going to use those metrics we built quite yet. We'll add that feature in at a later date. But for now, I wanted to get just something that will pull an item and allow us to get a game board back. So the very first thing we do is actually, we're going to do this inside of a try block because we want to catch any of those errors and make sure they're reported back. The API should always respond neatly, and it should always clean up after itself if possible. So any errors that we encounter, we're going to respond to the user with an HTTP 500 to say something went wrong and hopefully provide them enough detail to be able to go solve the problem, or at least report it back to us so we can update our code. But the first line in the work here is to actually create the random item. So the random item variable is just going to hold a game board, but Mongo gives us a really cool way to get something randomly out of a collection, and it's this aggregate function with a sample size. And so I can say, give me a sample size of 1, but when you do aggregate, it's going to just pull an arbitrary item and put it in the variable for us. I found that to be really enticing because I expected to have to do some wild randomness monkey math. How many items are in the collection, get a random number, do all this stuff. Mongo just takes care of it for me. I was really impressed and pleased to see that. So if the random item successfully is found, we have to defend against the case that maybe the collection is empty. So if it's found, then we're going to start this update process. And the first thing we have to do is make sure that we're handling the ID properly. So in Mongo, the _ID field is automatically created, but it's an object. It's not like a string the way you and I would look at it, or a number even. It's an object that needs to be parsed and treated differently. So we have to make sure that we're handling that properly when we do this work. But you can see the Mongo update 1 is very much like the add 1 from the previous thing, the previous endpoint, that we're just going to update this record. Now, why are we updating the record? I thought we were pulling it randomly out of the list. Well, the reason that we're doing this is because we want to set that last used and increment the access count. So you can see down below in the update, we're passing in the current date and time, and we're incrementing the access count. Okay, so after we did this update, we're ready to return the item to the end user or to the requester. So the first thing we do is we stringify the _ID field because we have to be able to pass something that JSON can parse, and it can't handle an object. So you have to go ahead and manually convert it to a string before you send it out. This is not anything that Mongo will be able to use, but it gives the user, if they're having to do some troubleshooting or something, or if they're wondering why they got this record, they can track it back using the ID field. So that gives them the ability to see that. Additionally, we have to make the same updates as we did when we updated the database, because when we updated the collection, it didn't change the item that we actually were working with. So we have to make those same updates in here just to make sure that it matches what we've put in the database. And then we're ready to return it. So you can see we return it in a JSON format, and we're going to pass along the HTTP 200 to say, hey, everything's okay. We're all good here. And then you see I've got the error message down here that correlates with the if random item up here. So If it wasn't able to find an item at all, then it will tell us no items were found and give them a 404. And then, of course, there's the exception. If anything caused an exception in here dealing with Mongo, then we capture that exception and we make sure we pass that information back to the user. This is going to be really important as we're troubleshooting, just to be able to see what those error messages were. And then, of course, down here at the bottom of the file, we've now finished our API for the moment at least. And so you can see that we've got the Python glue here that if they called this from main, they're going to do app.run, and the host is going to be the local box, and we're running on port 5001. But what we really want to do next is put this into a Docker file. Why? Because we want to spin up a Docker container that contains our API right next to our database container. And so you'll have these two containers that are prepackaged and ready to run, and it takes care of all of the environmental stuff. Like once you get the container to run right, you don't have to worry about will it work on their machine anymore, because as soon as they can spin up the Docker container, then they're good to go. So let's look at the Docker file and see what's inside there. So as I open up the Docker file, you can see that we're using an official Python runtime as our parent image. This means that it's going to be prepackaged and ready to run Python. It's already handled all of the bells and whistles. If you need to run a Python app, you just plug it in here and take off. You'll see that I'm using 3.12. I picked that one simply because that's the same version of Python that's running on my box right now. So in order to minimize the language compatibility, the potential for something to go wrong because of an update in Python, I went on ahead and just made sure they matched. Now after that, I set the work directory to /app because in the Python runtime, /app is where it's expecting you to load your source code. And so once I've done that, I'm ready to copy all of the files in my directory. So you can see all of these things here are what get copied into /app. And then I run pip install on the requirements.txt. I'm now loading all of the dependencies that are required. That's why we had to have that requirements.txt that we talked about a little bit ago. I expose it on port 5001, which means that the container will accept outside input on port 5001. And then there's several Flask environment variables that need to be set. Of course, you can change this to development, production, all that kind of stuff. You can reset these to be what you need. The other Python path, you want to verify that you are using /app there so that the Python runtime knows that this is on the path. And then finally, there's a command to run Flask. So I'm telling Flask to run and passing in the two parameters that it needs. The host is the local machine, which would be in the container at this point, and port 5001. And that's all it takes to run the Flask app as a separate container. Almost. We have to go over to our Docker Compose file next. If you remember from last week, this was the entire content of the Docker Compose. So we've added in a new service. So you can see we had a Mongo service before. We now have a Hangman API service. And the Hangman API service knows that its context is going to be the DB API folder. It uses a Docker file that's in there. The container name that it's going to create is hangman-api. It restarts just like the other one unless it was manually stopped. It uses the same environment variable or the environment variables file. The port is exposed. So just like we had to expose it from the Docker container itself, we also have to expose it from the Docker Compose environment that 5001 is accessible from the outside world. And one new thing that we're adding is a depends on statement. So this particular container can't start up unless the Mongo container is already running. And so depends on gives us the ability to put things in order that way. It says you can't start this one until that other one is ready to go. And if it's not ready to go, then this won't start up. And that's really important for the API because it has to establish database connections and things. And when you do that, if the database isn't there, then it's not going to be working. The volumes allow us to pass in the content of the code. So everything that you see in db-api is what's going to get posted in the /app. And the last thing is an environment entry that says you need to be able to reach the Mongo URI. And so this container has to know that it has access to the other container. And the way you do that is using the Mongo URI. Now I'm going to take a minute because I haven't really talked about that yet. And let's go look in the env file and we can see what the Mongo URIs look like. So Mongo URI by itself, this is what's used in the database container. It's going to be something that looks like this. Okay? And the interesting part about this is that one's on localhost. So if it's not on localhost, it's not going to work because this is the database container talking to itself. On the other hand, the URI / API has a slightly different look to it, and you can see it references it as Mongo. It's using the name of the service out of the Docker Compose file as the way that it references where this thing lives. And that's how you do that from a separate container. So that's why I needed to have two of these. I haven't really researched deeply to see if there's a way that I could simplify that and only have one. I don't know if the local host could be replaced with Mongo on this line. I kind of suspect that it might, but I haven't tested that out. And then, of course, you can see the other stuff that I've got in here. So I've got the root username, the root password, the database name, and the collection name that are all kept in the same environment file to be shared with all of the components in our application. So once you've done these things, I need to start up my Docker desktop here just for a moment. And you can see that my containers ran recently. I had them running a day ago, but we're not actually going to touch anything there. What we're going to do is come down here and you'll see I'm in the root directory of the project, and I just do the same Docker compose up -- build that I did in the last episode, and watch what happens. So it's having to do some building of containers, and I'll scoot this up a little bit so you can see. Everything seems to have come along nicely. All right, if I go over to Docker now, you can actually see both of my containers are running successfully. And I don't know if you've messed around in Docker Desktop, but you have the ability to do some cool things. You can go over here and view the details. So I'm looking at the log of this container. I can see all of the configuration files on the inspect tab. And in particular, like one of the places that this is really interesting is if you inspect and tap env, you can see the environment variables that have been passed into that container for its creation. So that's a really important troubleshooting step to be able to go, oh, did it start up with what I expected it to have in it? All of that's right here in the Docker desktop, easy to use. You can do all this from the Docker command line as well. It's just a lot of things to remember, and it's convenient to have everything here. So I've got this now running. I have an API and a Mongo container behind it. What can I do with that? Well, let's try pulling up a terminal here and seeing if we can test our data. So I'm going to do a curl. Oh, and you know what? I should probably make this bigger so that it's visible on YouTube. I'm going to do a curl, and I'm going to do HTTP localhost 5001 is my port. And if you remember, our path was random. And it randomly selects an item, and you can see I've done some testing here. My access count is up to 7 for this record. I think I've only got 2 records in the collection currently, but I had the hint is programmer quote, and the phrase is hello world. So in the game context, hello world would be the phrase you're trying to guess in Hangman. Hint would show up probably on the bottom of the page to say this is what kind of thing you're expecting to see in there. And it's got a last used date of today because it's now updated it to just now when I hit the button. And you can see there's the record. And so I can come in here and rerun this, and it actually pulled the same one. When you only have 2 records in the collection, that's highly probable. But that's the capability you've got. You can continue to test this, and you can continue to come up with ideas. Let's go ahead and test our other endpoint as well. And so I'm going to do a curl x post, and I need http localhost :5001/add, and then I'm going to do -h, and I'm going to pass in content type. So I'm establishing my HTTP header here, application JSON, and then I'm going to do /d, and this is the data that I'm passing in. So let's create a new one, phrase, and the phrase we're actually going to use is the adventures of Blink. And then we're going to do a hint for that, which is best YouTube channel ever. And then we close up our JSON like that. And there's the response we get, item added. So now if I go back and do a random selection, you can see it actually pulled that one. It saw a new record and it was like, hey, we'll randomly select that one this time. So there you have it. That fast, we're able to get an API running in Flask and hook it up to our Mongo database. And now you have the ability to just communicate with the database over HTTP. This is going to be really valuable later on when we build the front end game. When we got the Hangman game running, it can make simple requests to go hit the database. It doesn't have to worry about authentication. It doesn't have to worry about any of the heavy lifting. Do I have the right libraries in it? That's all handled by the API. All it knows is I go to this endpoint and it gives me the data that I want. And that's the kind of value that we want to build into our products. This is a small example, as we've talked about before, but imagine seeing this at scale, where you have the ability to have hundreds of endpoints in an API against multiple types of databases, perhaps, or multiple database systems that have different purposes. And you want to start aggregating and combining that data and doing more powerful magic with it. This is how that all begins. And these simple principles, while they look a little cumbersome in a tiny example, they set you up for success later on. When you build an API layer on top of any data source that you're using, it makes it easier for someone else to consume your information. And that's part of the journey here, is we're trying to make things easier on each other so that we can achieve more. I want you to consider that as you're building things for work. What's the interface that you're providing to the other engineers around you? Are you giving them an easy way to consume this data, or do they have a bunch of heavy lifting to do too? On that note, I think I'm going to call it a day. I hope you've enjoyed the show, and I'm so glad to see you here. Remember to click like and subscribe so you don't miss any future episodes. But I can't wait to see what you build with this, and I can't wait to hear what you've been building alongside me. We'll see you next time.